Okay, so I'm going to continue working with our point class example, but now I want to talk about separate files for class definition and class implementation. And actually, we'll draw a few pictures to talk about that. So far, what we've been doing is we've had a single file that contains everything. So in our single file, we'll have we always have some comments at the start, and then we define our class. So we have to both define and implement our class. And then we have our main program. And actually, if we have any free functions, their definition has to be in this file as well, and their implementation. So that's not very scalable. That works fine for a simple example where we have just one class, but it's not scalable. So what we do to make it scalable is we break up our application into multiple files, and it's not uncommon to have hundreds or even thousands of files. I've worked on projects where there's been over 1,000 files in the build. So this is very normal, standard, and it makes it much easier to find stuff and deal with stuff. So just to review, the way this works right now, this would be our, if we just leave it at the default name that Visual Studio gives it, this is source.cpp. And at build time, the compiler processes it, and that turns it into an object file, and then the linker processes it, and that turns it into a executable file. And the linker is also responsible for linking the standard library stuff with it. Okay, so the standard library is actually pre-built and in an archive. It would be called an archive in a Unix or Mac environment, a DLL in a Windows environment. But this is like a zip file that contains all of the .o files, all of the compiled files needed for everything that's in the standard library. So that I've included the definition of anything in the standard library I'm going to use using that #include directive. And then at link time, that gets pulled in or linked together. The .o object file gets linked together with my source CPP file. So what we're going to do now is we're going to move our point out. So we're going to have two additional files, one for the definition and one for the implementation. So the definition file is going to be called point.h, and the implementation file is going to be called point.cpp. So the definition contains just definitions or declarations. So it makes all the promises to the compiler about the methods and members that are available in that point.h file. So now when we use this, well, we can get rid of our definition and implementation that was put all together at the start there, and we just have to add a include file, an include directive, include, and the name of the file, the .h file. So that's this thing being included here. And we're also going to have to do that, include point.h here. So in this point.h file, we'll see, we write down the declarations of all of the method functions and members that are going to belong to this point.h. And then in the point.cpp file, we include them. Now at compile time, what's going to happen, the compiler step is going to turn that into a .o file. Okay, so that .o file has the implementation of all of the methods that are needed for point.cpp. And then at link time, this is the old way we did it. So at link time now, this is just one more object file that gets linked together with our main program that creates our executable. So that's how it all gets pulled together at build time. The sort of the glue, if you will, is this .h, or sometimes called an include file, definition file that contains all of the definitions. That gets included in any source file that's going to access and use our point class. And then our point class, the implementation, is in a separate file that gets compiled separately, builds its own object file, and then everything gets pulled together by the linker in the link phase of the build, and we get our executable. So it's very similar to what's exactly how we've been accessing the standard library. We put an include directive to say we're going to use that those objects or functions from the standard library, and then as part of the build step, the linker links together our object file with the standard library object file to pull in that implementation. Okay, so that's what we're going to be doing. And let's have a look at how to do that. So here I have opened up a new project. I haven't added anything yet. So we're going to start by adding the class, and then we'll add the main file after we have the class built. So still going to go to this add. Always before we did new item, this time we're going to do add a class. It's a C++ class that I want. And I just say yes, and then here I enter the class name. And the file name is going to be the same as the class name. Now, I can change that if I want, but I don't want to. Class names always start with an uppercase. They're a user-defined data type, and all user-defined data types are going to start with an uppercase letter. And our file names for the .h, the definition, and .cpp, the implementation, are also going to have uppercases. Okay, and we'll just finish that. So notice I get a point.h and a point.cpp, a definition and an implementation file, and Microsoft has put some stuff in here for me. So in my implementation file, it's included point.h for me. So already by default that include is there. And it started the implementation for a constructor and a destructor. And we started talking about constructors in the last class. Okay, let's move over to the definition file. And here in our definition file, we have the start of a definition. Here's the keyword class, the name of the class. The public section is already defined, and a constructor and a destructor are defined. Now I can just take these right out of here, and the compiler will generate or synthesize default constructors and destructors for me. But we're going to be building constructors, at least a constructor. Probably we'll just let the compiler do a destructor for us still. Okay, now I'm going to put a comment header in here. The file is point.h, and I'm going to say this is the point class definition. Now this is according to our style guide. We're going to have these header files in all of our files. That includes our class definition and class implementation files. Depends on where you're working, whether or not They'll have a style guide that will specify what you're going to do. Then the next thing we're going to put here is called an include guard. And I'll just type it in and then explain it. Okay, so now these are commands that start with a pound sign in the first column. So they are commands for the preprocessor. And this is an if statement. It's telling the preprocessor if this identifier or object, if this thing, point_h, all in uppercase letters, notice that's the same name as the file name. If that's not defined, then you do everything that's in between the beginning of that if and the end of the if. If it's already been defined, I skip over it. So I skip over the entire file. Okay, this is called an include guard. And the reason for this is so that oops, that's spelled wrong. The reason for this is so that the same definition doesn't get included multiple times. That would cause a compile time error. You'd be trying to define the same identifier more than once. And so the first thing I do, if this thing is not defined, that means I'm including this definition. So the first thing I do is define it. So I use that pound define and $h. And that way, once it's included once, the first time it gets included, that $h identifier gets created and defined, and then if it gets included again, this whole thing will be skipped over. All right, so that's just something you have to put at the beginning of every .h file you make. Now, by default, or you may see in other code, and when you create a class for the first time, Microsoft will put in pound, it's a pragma once. Okay, that effectively does the same thing. The only thing is it's a non-standard way of doing it. So your code will only work in Microsoft Visual Studio if you do that. This is a standards compliant best practice, and this will work regardless of what compiler, what build tools you use, or what platform you're on. So always do the include guard this way. Okay, so now we're defining. We're not implementing. We're only defining. So here's our constructor first, and I'll just maybe make a comment here. Start with constructors. And then the next section is going to be getters and setters. Okay, and then if I have any other functions besides getters and setters, I'll just call them other methods. And I'll go down here and I'll create a private. Okay, so the private place is where I'm going to define my member variables. In this case, we have the x and y coordinates. So int x underbar, which is the x coordinate of the point, and I'm going to have y underbar, which is going to be the y coordinate of the point. Okay, so those are my two members, and they're private. I'm going to have a setter. So setters don't return anything. So functions that don't actually return anything, we call void. Well, every function in C++ except the constructor returns something, but it doesn't return anything meaningful. So this is how we say it's not returning anything. Void set xy, And it's just the definition, so I can just say what type of parameters are getting passed. I don't have to give parameter names. I can just say 2 integers. Okay, I'm not going to have a getter, because a getter would have to return both x and y, and I can only return one thing. But I will have a display. Well, I could have separate x and y getters. I will have a display. It's also going to be void because it's not going to return anything, but it will display the xy point on the screen. And because it is only displaying, I can promise that it's going to be a const. And I'm not doing implementation, I'm just saying the definition, so this is all I have to say here. In the implementation file, I'll have to write the code for these things. And let's add a toArg constructor also, as we did in class and the other video. And the toArgs are going to be both integer. So I have my noArg constructor, and actually I don't want to allow constructing an uninitialized point. So I'm just going to cross that out. I guess it's a design decision. I could construct uninitialized points and set them to 0, 0. Yeah, why don't we do that? That's, I think, what we did in the last video. Okay, so I am going to have a noArg constructor. I'm going to have a toArg constructor. I'm going to have a setter that sets both x and y at the same time. And I'm going to have a display function. Okay, so this is all definitions. Now I have to go to my point.cpp file. This is where I do implementations. Okay, so first, my first constructor. Now, well, actually, even before I do any of that, I want to include my comment, my standard header comment that goes in every file. Don't want to forget that. Okay, this file is point.cpp, and it's the point class implementation. And I could put maybe a little more description later, giving some more information about the point class. Okay, so now the one difference, I'm including point here, but the thing I have to do now is all of my functions that I'm implementing, I have to prefix with the class scope. So here I'm going to say point : : point for my constructor. So because I'm not in the same file, I'm not doing the definition implementation in one place like I did before. This is the implementation, but I have to specify that this is the implementation for the point constructor function that belongs to the point class. Okay, and so for my noArg constructor, all I'm going to do is call setXY with 0, 0. Okay, and that's it. I'll just maybe comment here. Initialize to 0, 0. So if they use the noArg constructor, they're going to get 0, 0. Okay, I want to create now a toArg constructor. So point : : that's the scope operator. Point, the name of the method, so it's a constructor, it's just the same name as the class. And again, because it's a constructor, it doesn't return anything. Notice there's no return value in front of that. Okay, I'm going to have two parameters. Int, I'm going to call them tempx, and int tempy. And I'm still using this tempx and tempy because I really want to be clear that these are just really placeholders. Okay, and then The only thing that this constructor is going to do is call setXY and set the x value to whatever was passed in that tempx parameter, and set the y value to whatever was passed in that tempy parameter. Okay, so I have my 1R constructor, my 2R constructor. I'm going to let the compiler synthesize a destructor, because we haven't talked about those yet, so I'll just get rid of that. Okay, now I need to implement my setter. So my setter returns void. And if I'm not sure, I can go back to my definition and just have a look. So setter, this is what I have to implement. So it returns void, and I can copy and paste. Void setXY. I do have to specify the parameters again though. So my first parameter, again, I'm going to call it tempx, just to emphasize that it's just a placeholder, and tempy. And I can't have a semicolon there, I have to have the implementation. So this stuff here, where it actually defined what the function does, is called the implementation. This is my setter, so I'm going to take those parameters that are passed in, I'm going to assign them to the member variables. So x underbar is going to be assigned the tempx parameter that's passed in, and y underbar will be assigned the tempy parameter that's passed in. And later we could add more logic here. We could put some bounds on what are valid x and y values. Okay, and then I believe the last thing, let's go back and look. So that's our set x and y. The last thing we have to implement is display x and y. And that's also a void. It returns void. Oh, these things, you know what? Look, I forgot. I have red squigglies because I didn't say this set xy was part of the point class. And x underbar, y underbar, they're private to the point class. That's what happens if I don't specify this class scope. It thinks I'm trying to define a free function set xy that doesn't belong to any class. And this x and y are not defined outside of the point class. So I have to do this point : the class scope operator, and now those squigglies go away. Okay, so the last thing I'm going to do is define my display class, display xy method. And this one is just going to display the points. So I'm going to say std up. And now I'm using std_cout, and I haven't included it anywhere. So I'm going to have to come up here and include it. Include angle brackets iostream, which gives me the iostream stuff from the standard library. All right, and I'm just going to construct my output. I'm going to put some brackets around. I'm going to display this thing like a normal point, so in brackets and so on. Okay, so I bracket and then x underbar. Well, I guess you know what, it would be nice to have get x and get y function. So maybe I'm going to go back to the point, and I am going to define integer get x. Now it only gets something. It does not modify the object in any way, so I can make a promise that it's not going to modify the object by calling it const. And I'll do get y, and it's also const. I can make a promise to anyone who's going to use these that if they do use them, it's not going to result in any changes to the object. Okay, and since I've defined them, I can use them here. I'll still have to do the implementation, but do this first. So I'm going to do getX, which is going to return that integer x. And I don't have to specify anything here. It's the getX because I'm in the implementation for this part of the point. So that's going to operate on the current object. It's not ambiguous. So I do getX, and then I'm going to do add a comma and a space, and then getY, and then a new line. Okay, and that is the implementation of my display XY. Why do I have a squiggle there? Did I spell it differently? Display XY. Display XY. Okay, well, let's do my getX and getY. So those are both going to return integer. So int point getX, and I say, oh, that's why the one I defined I called const, so I have to call this one const too. My implementation has to match my definition. So and getX is just going to return x underbar. Class scope operator, and getY. I also promised that I would make it const, so I have to make that promise again here. And just return Y. Okay, and that's my implementation. So I can just double check. In my definition, I have said that a point class constructs of a no-arg constructor, a two-arg constructor, these three getter and setter methods, and this display method, and two integer members, x and y, that are private. Now I go over into my implementation, and notice this is, in the definition is the only place where I have to declare member variables. In the implementation, I just use them. Their declaration is enough. The only thing I have to implement is functions, method functions. So I've had to provide an implementation for every method function that I use. And I have to use the scope operator, and I have to include point.h. So now I have to add a main function so that there's a starting point and I can actually run a program. So this time, whoops, didn't want to add a class again. This is back to what we've done before, add a new item. And the new item is a CPP file. You can leave it as source if you want. I'm changing my name to be point demo. It doesn't really matter what it's called. What matters is that it contains that function int main, the one function that has to be there. That's the start of every program. Okay, so I am going to use standard in and standard out, so I need the IO stream. And I'm going to use my point class that I just defined. So to bring that in and make it available to me, I do include point. Now I have my int main. That gets implemented in this block of code between these curly brackets. And I'm going to end with my kludge that we seem to always need. Okay, so this is just asking the user for input, and it's only there to hold that console window open so we can see what the program has done, and then when we're done we hit enter and it goes. I'll put my same comment here just to say that's a kludge. Okay, so I'm going to create a point. Let's see, point, I'll call it 1, and I'm going to use the toArg constructor, and he's going to start at 42, 73. And I'm going to, let's create another point right away. Oops. This time I'm going to not use any the noarg constructor well, I wanted to say default. It's not the default. I created it, so it's not the constructor synthesized by the compiler. We created a noarg constructor. I should get rid of that. Visual Studio puts the word void in there, which is okay, but it's more normal to just have it empty like that. You'll see this more often for noarg. So we created, there's the definition, and here's the implementation of the, here's the implementation of the noarg constructor, and I'm implementing it, I'm setting it to 0, 0. So when a noarg constructor is used, the point 0, 0 is set. Now I'm going to display, I have to use an object. An object can display itself. So I'm going to display point 1. I'm going to say 1.display. And then I'll also display point 2. I'll say 2.display. And I guess that's it. Let's just build it and run it, and then we'll be done. Okay, so it builds successfully. And we'll just do run. Move these over here so we can see them together. And, oh, I forgot to put my closing bracket. I'll go back and fix that. But everything else is working. So I create this point 1 that's 42, 73. I create point 2 using the noarg constructor. I don't pass any arguments. I display 1 first, and sure enough, it's 42, 73 as I expected. Then I display 2, and it's 0, 0 as expected. And I just want to fix up my display point, and it needs to finish with a closing bracket. And let's rebuild and rerun that and just make sure that looks okay now. Okay, same results, and now I have that nice closing bracket. Okay, so that is how we normally define classes. That's in a separate implementation and definition file. So the definition file is the .h file, and it contains only the definitions. So definitions of any members, which is really all there is for a member is a definition. There is no implementation. There's just a definition. But then for all of the methods, I have in my .h file, I have just the definition. And this is the only place where you see that class keyword. This is where the class is defined. So I'm defining a new class called point, a new user type called point. I'm promising that there's going to be all of these members implemented somewhere, or pardon me, methods implemented somewhere, these functions that are going to belong to this class, things that the class can do. And I'm defining the members that are going to be part of that class. And then in my implementation file, that's the point.cpp file, every function that I promised I would have an implementation for has to be implemented here. And when I implement them, notice I include the definition so the compiler can make sure I am implementing things for that definition correctly. It'll give me error messages if my implementation identifiers and signatures don't match my definition. And when I do these implementations, I have to specify the class that that member is part of. And I didn't have to do that before because I did the implementation right in the class definition. But because I'm not doing it in the class definition, I'm doing it in a separate file. Every single one of these, including the constructors, I still don't have a return type for my constructors, but I do have to use this class scope identifier. Okay, so that is how we set up and use separate definition and implementation files for our classes. And we will normally do that for every class that we define. So if a project has 5 or 10 classes, we would have 10 or 20 extra files, 5 or 10 implementation files and 5 or 10 definition files. So for every class, we're going to have, and that's, technically, you can put more than one class in a file in C++, but the best practice is not to. And then in some other languages, for instance Java, each class has to be in its own file. In C++, I can break things up any way I want. I can have all my classes in one file. The file name doesn't have to match the class name. But all of those are bad programming practices. And that's one of the things they did in Java. They made a rule that your file name has to match your class name and you have to have a file for every class. And so that is a best practice in most places that are doing C++. They follow that practice where one class per file and the file name matches the class name. And we have a implementation file, classname.cpp, and a definition file, classname.h. Okay, so that's it for that.